So we're going to take a look at Chapter 1. Okay, we're going to do a quick review. If you take a look at what's in the book, I'm not covering everything that's in the entire chapter. Okay, just some of the more important things that will come up. Okay, so one thing you really want to know is what is a variable. Okay, a variable is something that's going to come up a lot in algebra. Okay, a variable is any symbol that we use to represent something we don't know. Okay? A lot of times when we have a variable, we'll use a letter. In algebra, we use letter X quite a bit, but we could use any letter we want. X, Y, M, Z. Okay? And a variable just represents something you don't know. Okay? Certain letters you might want to be careful about using. Anybody think of a letter that would not be a good choice to use as a variable because it could be confused with something else? Yeah, let me try to learn some names. Save on.
Oh.
Yeah, letter O. Letter O is not a good choice for a variable because it's going to look like the number 0. Okay. Yep, an L. So depending on how you make some of your letters, an L could look like a 1, things like that. Okay. Generally, I'll try to draw a Y like that so it doesn't look like an X. Some people make a Y like this. That looks fine, but if you start to get a little sloppy with your Y, now I'm not sure if it's a Y or an X. So I'll try to be very clear when I draw a letter. Okay. Any questions on what a variable is? Okay. So if we take some variables and we start to put them together, we can get what's called an expression. Okay. An expression is when you have one or more variables. Okay. And then you have one or more operations. Okay. An operation is when you add, when you subtract, when you multiply, when you divide. Those are the basic operations. Okay, so here's a few examples of expressions. Okay. X. The reason X is an expression is because it says right here it contains one or more variables. Is X at least one variable right there? Yeah, that's one variable. Okay. Sometimes we'll have more than one, but all we need is one for a very simple expression. 2x. Okay, that's also an expression. Okay, what does it mean when you put a number right next to a letter with nothing between the number and letter? What operation is that? Clayton.
Multiplication.
That's multiplication. 2 times x. Very good. Okay, that's an expression. Here's another expression. 5 plus y. Okay. Contains one variable, just a y. And in this case, it contains exactly one operation, addition. Okay? This last one gets a little bit more complicated. It's got a couple variables in it, x and y. It's got subtraction here. What about here? 8 right next to x. What did we just say that means again? That's multiplication. So we got multiplication here. How about 3 right next to y squared? That's also multiplication. So there's a ton of operations here. You got multiplication here, multiplication with 3y squared, and a subtraction sign. So these are all what we call algebraic expressions. Right? Anything that's got a variable in it, it's an algebraic expression. If I wrote something like this, that's not an algebraic expression because it does not contain one or more variables. There are no variables in 2 plus 4. That's a number. 4 is a number. No variables there. Okay, so to be algebraic, it's got to have a letter in it. And a lot of times when we have an expression, they're going to ask us to evaluate it. Okay, what that basically means is to take a number and plug it in for the letter. All right? And a lot of times I'll tell you, or Mr. Roy will tell you what number we want you to plug in for that letter. Right?
Or sometimes, guys, they might say, when you actually have to, you solve for the variable. Like we'll have things this year where you solve for the variable, and then you're going to have to evaluate. So you have to do 2 steps. You'll have to solve the equation, take what you got, plug it back in, and actually get a number for your answer. All right? So sometimes you have those 2-step problems. So evaluate this means basically plug it in. Easy.
So when we ask you to evaluate, you should be coming up with a number for an answer. Okay? If you have letters after you've evaluated something, something's not right. Evaluate means to find a number. Okay? Finding a number. Any question on that? Okay, I'll show you guys an example. We're going to evaluate this expression, 2xy. And we wrote down what we want you to evaluate it for. Okay? We want you to let x equal 4 and let y equal 3. Okay, I'm going to make that a little bigger, but does everybody have what it means to evaluate an expression? You got it? Okay. Okay, so what's the first thing you have to do to evaluate an expression? Yes, Clayton.
Plug in numbers for the variables.
Right. What number are you going to plug in for x?
4.
Right, so 4 is going to go right there. And what number are you going to plug in for y?
3.
3 is going to go right there. So we're going to have 2. And now, when I plug it in, how should I do it? Should I just write like this? Plug in 4, 3, 2, 4, 3?
Put the multiplication sign next to it.
Yep, you can put a multiplication sign between them, which is a dot. What else can you do besides the dot? Yeah,
Put 4 in parentheses.
perfect. Put the 4 in parentheses. You don't even need to put the 3 in parentheses. That does it. If you want, you can. It's up to you. But if you don't put those parentheses in there, it looks like the number 243. Okay?
Hey, Wyatt, does it matter how Mr. Hager does that? Does it matter how he does his math?
Not really.
Well, what can he do first?
Oh, both inside the parentheses,
He can multiply the parentheses first, sure. So what would he multiply? What two numbers?
4 and 3.
4 and 3. What's he gonna get? 12.
You notice I still need to put parentheses, or I got to put a dot, or I got to put something. I don't like to use the dot as much, especially when we have decimals involved. Because then you've got dots that represent multiplication, you've got dots that are decimals. Too many dots.
It's a mess.
It's a mess. Okay, so parentheses I think looks a little cleaner. And now we only have one thing left. We don't have any choice here. Okay, what's 2 times 12? Yeah, Marcus, 24. Okay, and that's it. That's how you evaluate an expression. Plug in the numbers, do out your arithmetic, get your answer.
Hey guys, he could have done it together. He could have done it the other way too, right? He could have done 2 times 4. Would have gave him what?
8.
8. Then 8 times 3. 24. Same deal, right? He could have gone a different way. That's fine.
Yep.
Because it doesn't matter which way Mr. Hager goes there, left to right, right to left. How come?
You're gonna get the same answer.
But why is he getting the same answer, Isaiah?
Because there's multiple ways to do it.
There's multiple ways to do it, but look at, there's only one operation up there, right? You're gonna say that, Caleb?
No, you're also not changing the numbers with the same concept.
Exactly. It's all the same operation. It's not, you don't have to use order operations. You don't have to, it's not multiplication and division. It's all multiplication. So you can do it any way you want. It doesn't matter.
As Mr. Roy said, if it's not all the same operation, order of operations, something he said that's very important. So when we start mixing addition with multiplication, with division, with subtraction, then we got to be very careful. Okay, but that was all multiplication. Okay, so multiplication and addition work like that. If you want to add 1 plus 2 plus 3, you can add them up in any order you want because it's all addition, just like we did with multiplication. Okay. Sometimes when we take a look at some word problems, okay, they're going to give us something that's written as a sentence. For example, x increased by 2. And they're going to ask us what increased by means. What operation do you think that would be? If you take x and you increase it by 2, you're adding, subtracting, multiply, divide. Matthew?
Addition.
That's addition.
Yeah.
Okay? So we're going to just look at some basic phrases like that.
Guys, what's some other like actual English expressions you've heard in math? Or some other ones that might represent an operation? We just had increase by, which was multiplication. Say on?
Decrease by.
Decrease by, which would be what?
Subtraction.
Subtraction, right? What if I said twice? If I said twice, 3 times, anything like that? What's that represent? What operation? For what operation? We only have 4 choices. Caleb? Multiplication, right? And again, I'm telling you guys, twice, 3 times, it shows up all the time in word problems. Know that it's multiplication, right? Know that that's multiplication.
So we're going to show you some different examples. You don't have to write them all down. You guys just said a lot of them when Mr. Roy asked you. But the first one is additions. You guys gave increased by. That was one of them. Another way is to say plus. X plus something. That means addition. Added to. 28 added to X. That's another way to say addition. Increased by. That's what you guys had said. More than. 28 more than X. Means to take X and increase it, make it more, 28 more. Okay? The sum. Sum is another one that you'll see quite a bit. The sum of 2 numbers. Sum means to add.
Yeah, sum means like when you add the 2 things together, that's what you get, the sum.
And this whole table, that's in your book. So you don't have to memorize it. If you don't get it down, that's fine. It's all in your book, and we're going to see these words throughout the year.
So,
yeah.
Right. So like Mr. Hager just went down to the next one, right? Next one's multiplication, right? So if we're talking about sum for addition, what do we say for subtraction? What do we get when we do subtraction? What do we call that? The difference, right? The difference between the 2 numbers.
Perfect. So you got difference. It's basically all the words up here. Just take the opposite of them. Instead of increased by, you can say decreased by. Instead of more than, you can say less than. If I said, what's 2 less than 10? What would that be? That's 8. You do 10 minus 2. And that's how you get it. 2 less than 10. Difference. Okay, that's the word Mr. Roy just went over. Difference.
So,
Okay?
hold on a second, Mr. Hager. So we go to the next one, right? What's the next operation? We have 16x, we already said it. Multiplication, right? So we had sum, we get the answer for a addition problem, it's a sum. We do a subtraction problem, it's the difference. What about multiplication? Anybody know? It starts with a P. Yeah, product, right?
Product, yeah.
So we have sum, difference, product.
Very good. So product, you're going to see that way a lot. You could see times. A lot of people say times, like 5 times 2. That means multiply. Or you can just say the word multiply. 16 multiplied by 3. Okay, all different ways to say multiply. And then the last one we've got is division. So what is it?
He's on the right track. Right? He said, what's the equivalent?
Yeah.
Sort of sounds like that. Right?
Similar to that, yep. Clayton? Quotient. Yep.
You're on the right track, though.
When you divide 2 numbers. Like if I take...
I didn't want to say because I wasn't sure. But I was going to say quotient.
So that's perfect.
I'm
Quotient.
going to look bad in the second page.
Okay. There's not as many ways to say division that we're going to use. We usually use quotient, or we'll just say divided by. Those are the common ways. Okay. Any questions on all those different ways?
Hey guys, don't panic. We're not going to see word problems right away.
Yeah.
Relax.
We're not going to do them right away. When we do them, we're going to go really slow.
Yeah.
We're going to spend a lot of time. We're not going to rush through it like we're going to rush through chapter 1 right now. But we're going to go really slow through word problems. Okay? Nice and easy. Okay, so let's look at this one. Okay, let's see if we can figure out which operation it would be. It's adding, subtracting, multiplying, and dividing. Okay, it says the cost of, you're getting P pounds of tomatoes, and it's 79 cents for every pound you buy. Okay, so think about it for a second. If you bought 1 pound of tomatoes, how much would that cost you? 79 cents. If you bought 2 pounds, what would you do with the number 79 to find the cost? You double it. And what operation is double? Multiply. Okay. If you bought 3 pounds, what would you do with 79? 79 times 3. 5 pounds, it'd be 79 times 5. If you bought P pounds, it would be, yeah.
Do P, then put 0.79 differences.
Yeah, you do P times, and if you want to do it in dollars, you can make it 7.79, or if you just want to keep your answer in cents, just like that. So there's an expression that tells you the cost of buying P pounds of tomatoes. If you buy 300 pounds, it's 300 pounds times 79 cents. Okay. Any question on that expression? Okay. So you don't see the word multiplied by in here, but you got to know that it's multiplication. Okay, y years less than x years. Yeah, we're definitely thinking subtraction. We're thinking subtraction. And what I do if I get stuck trying to figure out what, is it x minus y or is it y minus x? I put in some numbers. And I think of what it would be if I use the numbers. Okay? So let's look at it with numbers. What if I said 1 year less than 8? What's 1 year less than 8? Yep. 7. Okay. So how did you get that? Did you do 1 minus 8 or 8 minus 1?
8 minus 1.
You did 8, which was that one, minus 1, which is that one. Okay? That's a tricky one. Less than is tricky because the order you see it in, you see y, then you see x, but that's not the order you write it in. So that's why if I get confused, I try it with numbers and I think it through that way. 1 year less than 8. To get 1 year less than 8, I know that's 7. Right? So how do I get 7? Do I do 1 minus 8? No, that's not going to work. Do I do 8 minus 1? Yes, I do. Okay? That one's tricky.
Whenever the trick is, whenever you see less than, know that whatever comes after that, when you're setting it up, it's going to come first in the problem, right? Because it's not asking for, because if we put it the other way, it would be -1. You don't want that, or -8. You don't want it to be negative, all right? So when it says less than, always put the second part first.
Yeah, that's a tricky. That's one of the trickier ones to remember. Here's another one. 3/4 the number of students. Okay, the key right here is this word of. Does anybody know what that usually means in math? Of. Savon? Like if I said to find half of 10. Not division. If you take, what can you do with 1/2 and 10 to get the answer? What is half of 10? 5. So what would you do with 10 and 1/2 to get 5 as an answer? No, not. If you divide them, you don't get 5. You multiply. Exactly. This is multiplication. Of means multiply. Okay? So in this case, it's 3/4 of, which means multiply, s. So 3/4 times what? Times s. Yeah, s is another letter. You got to be careful because it can look like a 5. Okay, that's my s. That's my 5. Okay. So of, make sure you know that. Write that down. Of means multiply. Okay, and I think that's good. Okay, so Mr. Roy said earlier, when you do arithmetic, if you start mixing addition, subtraction, multiplication, there's an order of operations you need to follow. Okay, this is something you want to take down on that sheet.
On that sheet, in that first box, I want you to put concept. What concept are you talking about? What big idea are we talking about right now? Up on the board.
Oh, arithmetic. Calculations. Arithmetic.
Order of operations. So in that first box, our first big idea is order of operations. And I think before Mr. Hager even pulls that shade down to look at this, I bet you guys already know. What is it? What's your name, buddy?
Clayton.
Clayton. Clayton. Clayton. Pemdas, right? P-E-M-D-A-S. How do people remember it? How do you remember it? Marcus.
Parentheses.
But how do you, what's the little like thing that helps you remember it? I mean, each letter stands for something, right? Please what? My dead Aunt Sally, my dear Aunt Sally. Any others? Besides those? Where'd you go to school last year? Overlook? Wow. What, like deaf up there or something? Yeah. What did Aunt Sally do? Pass gas or something? That's why you're excusing her? I'm just kidding. All right, so guys, first one, P stands for what? Parentheses. I guess spelled that right, I'm not sure. So parentheses, E stands for what? Exponents. D, I mean M, yeah, it's the word I skipped one. M what? Multiplication. D, division. A, addition. And S, subtraction. Right? When I'm doing order operations, what order do I go?
Start from the P and go down.
I know, but when I'm doing the actual problem, it's actual numbers.
Oh.
Which way do I go? I'm looking at it. I go from
Left to right.
left to right.
How do you do it?
And that's really important with multiplication and division. You always do those two together, left to right. Okay? Same with addition and subtraction. Those two are always done together, left to right. Okay? And along with your parentheses too, if you see a bracket, that's also a grouping symbol. Okay? In general, any parenthesis, bracket, even if you see a fraction bar is a grouping symbol. Okay? Generally, when I have a fraction, I simplify the top of it first, then I simplify the bottom of it, using the rules we put right on the board. Okay, so PEMDAS, it's very, very important for doing calculations. Okay? This PEMDAS, I don't want you to confuse it with solving an equation. That's very different. PEMDAS we use with arithmetic. 9 times 2 divided by 3. That's PEMDAS. Okay? 2x equals 10 plus 7. That's solving an equation. Okay, so we're going to talk more about solving equations, but want to make sure you guys don't confuse PEMDAS with that. This is for arithmetic.
So guys, the one thing I just added down the bottom, Mr. Hager talked about those brackets. All right, if you see those brackets, again, that's a group. Like he said, it's a grouping symbol. You want to use your PEMDAS. All right, so just keep that in mind when you get something like that. That's all.
Any questions on PEMDAS? Okay, let's try a couple. Okay, so I threw a grouping symbol in here right away. I threw a fraction bar in there. What did I say I generally do when I have a fraction? What do I start with?
Parentheses.
Well, so you're going to start with the top?
Yeah.
Yep, that's perfect. So you're going to start with what's inside those parentheses. For now, keep everything else the same. Okay, we'll do one step at a time. What's 13 minus 7? 6. Very good. I need to leave it in parentheses so we still know it's multiplication. Okay, I still have that fraction bar there, and I still have more work to do in the top. So whenever I have a fraction, I like to finish up the top before I start the bottom. Okay? So what do we have left to do in the top? Yes?
2 times 6.
2 times 6, which gives me
12.
12. So now the top is done. Top's going to stay the same the rest of this problem unless we can reduce it in the end. But I'm going to keep it the same for now. Next step in the bottom. Do I do 15 minus 6 or do I do 6 times 2? Yeah, Clayton? 6 times 2, which gives me 12. 12 in the top. 15 minus 12 in the bottom. Okay, what next? Yep, say one.
Subtract
15 minus 12, yep, what do you get? 3. Now, we've simplified the top and the bottom separately as much as we can. Sometimes you get an answer that's going to work out nice. Okay, if you can reduce it, we reduce it. If we can actually calculate that, we're going to do it out. Okay? Can we do 12 divided by 3 and get a nice answer? What do we think? Yeah, Laura. Yeah, you can do that out and get 4. Okay, so to get full credit on a problem like this, this is what we would expect to see. You go all the way down to that final answer. If you stop here, you're going to probably lose a point. It's not quite done. Okay, so if it says simplify, you've got to go all the way through.
And guys, any time during the year, when you get a bigger number on the top, a small number on the bottom, always double check to see if that small number on the bottom can go into that bigger number. We start getting in the second half of the year, especially when we do like, what is it, slope-intercept form, like graphing a line, it's really important. All right, always look. Now, Mr. Hager, I'm getting ahead of myself here. Mr. Hager wanted to make that 4. If you want to make that a fraction, what would he do? Somebody besides these two guys, I know. Why? What do you think he'd do? If you want to make 4 a fraction, what would he do? He only has to do one. He'd have to make two lines with his pencil. That's it. With the smartboard pencil. That's all. 2 lines. He could be super lazy. What do you think he'd do? Chelsea, what do you think? Huh? Put it over 1, right? Just draw a line, put it over 1. Whenever you want to make a whole number a fraction, all you got to do is put it over 1. It's that simple. All right? And again, it may seem like, oh, that's super easy. Why is Mr. Roy wasting his time? What's he think we are, babies or something? Think we are stupid? Believe me, I'm telling you, second half of the year, people forget it. I'm telling you, it happens.
You do. Okay, let's take a look at this one. So again, another fraction. So we're going to start at the top. What's the first thing we should do in the top? Yeah, go ahead, Matthew.
The exponents.
Yeah, we can do the exponents. Can you tell me what do they come out to? What's 2 cubed?
8.
How much?
8.
8, yep. Perfect. And
Isaiah, what's that mean? 2 to the 3rd power.
That you multiply like that same number by itself.
Right?
Yeah.
2 times 2 times 2.
Yeah.
3 times. That little number, all you do is take that big number, the base number, and multiply it together that many times. It's not 2 times 3. It's 2 times 2 times 2. Because that number, that exponent's 3, multiply the base number that many times. That's all you're doing. Don't do 2 times 3. Big no-no.
okay, how about the next one? What's 4 squared? Yeah,
16.
perfect. 4 times 4. As Mr. Rice said, not 4 times
It's
2.
all over. Nice job, bud.
Okay. All right, top, you've done as much as you can. We did 2 things at once. That's okay. We did our exponent here. We did our exponent here. Okay. How about in the bottom? What's the first thing you got to do there? Yep, Clayton.
The parentheses, 5 minus 30, which would be 2.
Would be 2. Okay, so I still have my exponent, but I just did what's in parentheses. 5 minus 3 is 2. Okay, let's take a look at the top. We have 8 plus 16. Okay. Can we do that before we do 2 to the 2nd power?
No.
What do you think?
What operation do you have on the top, Isaiah? What kind of operation is that?
It's addition.
Addition, right? On the bottom, somebody that I haven't heard from yet. Tell me what operation you have on the bottom. My man in the front, in the red. What's your name? Ryan. Like, oh man, you picked me up now. Man, I thought I was going to be home free. Another half hour, I would have been out of here. All right? On the bottom, what kind of operation you got? What is that? Based on our order operation list, what is that on the bottom? Exponents, right? So, which one are you going to do first? Yeah, it's an exponent, right? That comes first, we'll do it first. What do you get? What's your bottom number going to be now? 2. Careful. What do you do? That means what? I just had Isaiah tell me a little while ago, he said 2 to the 3rd power was 2 times 2 times 2. So 2 to the 2nd power is going to be what? 4, right? 2 times 2, 4, right? Okay, good. We're on the right track. I know it's getting late in the day, my man, but hang with me. Okay?
And then in the top, what do we get? 8 plus 16. 24. Okay. Can that be divided 4 go into 24? Does that work?
Yes.
Okay. How many times? Yeah. Go ahead, Laura. 6. Okay. Very good. Okay, so that's some basic order of operations kind of problems.
Having class one in their own, Mr. Hager?
You guys want to try this one? Okay. So try to do that one.
Guys, it doesn't have to be, you can do it on a folder or something, on a scrap piece of paper. We're not gonna collect it, just write it
Yeah.
on something.
Okay. Just try to evaluate that. 3x squared minus 2x plus 1 when you let x equal 4.
Yeah.
Okay, so as we walked around, it looked like a lot of people were getting it. Let's take a look. Okay, notice the first thing Mr. Roy did? He filled in 4s everywhere we had an x. Okay. Now we got to decide what's the first thing you do in this expression. Follow Pemdas.
Isaiah, what's the first thing he's gonna do?
Follow Pemdas.
Awesome, thanks very much for that. What's
But
that
then-
commercial? Thanks, Captain Obvious.
Oh, no. Oh, yeah. No, but you do your exponents first.
What do you get?
You get 16.
Thanks, man.
Sometimes we do more than one step at once, but let's just try to do one step at a time to try to keep it simple. Okay, what's the next thing we do? Yeah, Clayton?
You, the parentheses on the same side.
Yeah, we can do the parentheses here, sure. So go ahead.
16 times 3 would be 48.
Yep. And you got another set of parentheses right here, which we can do at the same time. This is all multiplication, this step and this step.
2 times 4 would be 58.
Okay. Now, this is the step where you got to be careful with Pemdas. You don't always do addition before subtraction. You do them in order left to right. That's how multiplication and division works as well.
What do you think, Kayla?
You subtract the 8 from the 48, which is 40, and then you
Yep, then you add 1, 41. Excellent. Okay, so there's an example where you're evaluating and get a final answer that's a number.
Guys, a lot of people did that 3 times 4 first, and then they did the square root, right? You can't do it. You gotta do those exponents first. All right?
Okay, so next thing that we're going to show you are some properties. I just want you to look at these properties. I don't want you to write them all down. I'm just going to go over some quick examples, and I want you to understand, kind of like touching on some things we already did. Okay, first one is called the commutative property. Okay, I think we looked at something like this earlier. Basically says if you add two, or we did multiplication, but if you add two numbers together.
So guys, from the first part to the second part, what's happened?
You're adding the same numbers together.
You're adding the same number. What about the order?
It's backwards.
Huh?
It's backwards.
Yeah, just flipping it, right? All the commutative property is showing is flip the order, and you still get the same answer, right? Doesn't matter if it's 3 plus 4 or 4 plus 3. You're still going to get what? 7, right? You're going to get 7 on both sides.
Right. So the order which you add them up, that doesn't matter. Next property I want you to look at right here. Notice the order on each side is exactly the same. 1, 2, 3 on the left. 1, 2, 3 on the right. There's no difference in the order. What is different? I just want you to look at what's different. Yeah, Katie. Right, it's where we've put the parentheses. Okay, grouping. That's what the associative property is all about. How are you putting your parentheses in there? And watch what happens if you do it on the left. What's 1 plus 2? 3. What's plus 3? 6. Now try it over here. If you do what's in parentheses first. 2 plus 3? Plus 1? 6. So what I'm showing you is where you put the parentheses when you're adding something up. It doesn't matter. Okay? And that name for that is called the associative. Okay? We have the exact same two properties again. Now it's with multiplication. And this one I know we did earlier. We looked at it. Okay? The order has just been switched again. 5 times 2, 2 times 5. Same thing. The order in which you multiply doesn't affect the product. Okay? Now, if we start throwing in addition and division with this, then you got to be careful. But this is just multiplication. Okay? and one more for multiplication. Just like we did before, let's look at the order. What's the order of the numbers on the left? What order are they in? Yeah, Clayton? Yep, what are they? First number.
6 times 4.
Well, 2, then 3, then 4. Order on the right? 2 times 3 times 4. Order is exactly the same on both sides. All we're doing is changing which calculation we do first. If you do it the way on the left, or you do it all the way on the right, you're going to get the exact same answer. Okay? 2 times 3 is how much? And what's 6 times 4? 24. Okay, let's do it on the right. What's 3 times 4? 12. What do you get if you double 12? 24. Okay? So those are two important properties. Let's get that. Okay, this is another property that's really important. This one's going to come up all year long. Okay, distributive property. Okay, distributive property is when you've got a number on the outside of parentheses. And then inside here you have addition, or you could have subtraction. That's the only way distributive property works. Number on the outside of parentheses. Inside you're either adding up a couple things or you're subtracting them. Okay? And I already kind of did it out, but the idea is sometimes we draw lines in to kind of show it. Has anyone ever seen that before? Draw a line like that. Okay, what that means to do is do 4 times 3, okay, which I did there. 4 times x, which I did right there. Okay. Now 4 times x you can't really do a lot with, just 4x. What about 4 times 3? 12. Okay, exactly. Okay, so I want you guys to try another one. What? Let's change it to that. 7 times 8 plus x. Okay, what would be my first step? Yep, 7. 7 times 8. What's going to come right after the 7 times 8? Something before we put another number in there. That symbol you see right in the middle there. If that's a plus, then we use a plus here. If that was a minus, what would I have used here? A minus sign. Okay. Now what do we put? 7 times x. When you multiply a number times the letter, that's all you can do. 7x. Okay. Any question on that?
Don't we give an answer for it?
That's it? That's as much as, well, you want to, oh yeah, 7 times 8. Sure, we can do that out. What's 7 times 8?
56.
Okay. Okay. Now I look at this one. This one's a little different. What we're doing in this one is we're kind of taking something we have here and we're changing it back. Okay, so you want to look at what they have in common. These both have a 7 in common. Notice that's the number that ended up by itself on the outside. Okay. What do these both have in common? 6. That's the number that's going to end up by itself on the outside. Okay. What symbol you think we're going to put inside here? Addition. Why? Because we had addition right there. What's going to be my first number?
4.
Yep. My second number? 3. So you guys just use the distributive property the other way. Okay, this is one way to do it. And part A is the first way we did it. Okay, any question on that? Okay. All right. And last couple things we're going to finish up with are what are called the terms in an expression. Okay. We're going to look at this expression right here. Okay. 7x plus 13xy squared plus 18. That's the example that's in your book. The parts of an expression that are connected by addition and subtraction signs are called terms. Okay, so let's see if we can figure out how many terms we have here. Anyone have a guess what the first term is in that expression? The first thing you see before you hit an addition sign. All of it together.
7x.
7x. That's your first term. Okay. What about your second term? 13.
X,
Keep going till you hit an addition or subtraction
Y.
sign.
2,
xy, how do we say that?
y squared.
Yep, y to the second or y squared, same thing. Right? Is there any other term here?
18.
18. This is an expression that has 3 terms. So if I ask you, what's the first term? I'm asking, what's the first thing you see before you hit an addition or subtraction sign? Okay, question. Okay. Okay. What do you notice about the 18 that's different than the first 2 terms? Exactly, doesn't have a variable. Okay? When something doesn't have a variable, variable means things are changing, right? Variable speed fan, you can change the speed. Okay? If something doesn't have a variable, it's always staying the same. Something that stays the same all the time is called a constant. Constant, never changes, constant, stays the same. Okay? So this last term right here, it's called a term. More specifically, it's called a constant term because it has no variable. Okay? Or you can just call it the constant. Constant term, same thing. Okay. Any question on the idea of term or constant term? Okay, so that's what terms are. They're separated by addition and subtraction signs.
Hey guys, I put it up there. The sign, you gotta think like this. Let's go back up for a second, Mr. Hager. This, like, the sign to the left, whether it be negative or positive, is like, you gotta think of it like these two, like the sign to the left, whatever's to the right of it, it's like they're on a date. Like they're together. They're staying together. All right?
Cute.
So this guy, that guy is attached to that guy. That guy's attached to that guy. All right? So remember, these two sign to the left is, again, once you get into the bigger problems, especially when you start solving equations, all right, the sign to the left is always attached to what's to the right of it, whether it be a variable or whether it be a number. They're always attached. All right? Now what about this? What about this 7x? What is that? Positive or negative?
Positive.
Positive, right? Why?
There is no negative sign in front.
There's no negative sign, right? It's just like, why is $1 a dollar? It's just a dollar. Why is today Wednesday? It's just Wednesday. You don't have to explain it, just because it is. That's the way it is. So if there's no sign, it's positive. If there's no sign in front of it, let's assume it's positive. So sign to the left always goes with it. Again, at the beginning, guys, what I do is I circle the number of the variable and what's to the left of it so I don't make that mistake. When I do all this work, I don't want to get to the last step, make a mistake in my signs, and me know Mr. Hager takes off 3 points on the test. I don't want that.
Okay, so you guys, any questions on what Mr. Roy just said? Good? Okay, so last thing we're going to look at are a little bit more specific thing about terms, okay, what we call like terms. Okay, so like terms. I'm going to give you the definition, and I'm going to show you guys some examples. Okay, very simple definition. Like terms have the same variables, and those variables have the same exponents.
So guys, if I said 12, all right, if I said 12, Chelsea, what's a like term of 12?
Think about something you could add to 12 and get an answer.
Give me a number, any number you want. 1. 12 and 1, like terms, same thing, right? 1,003 and 1,000,001, like terms, all right? What if I said, Marcus, what if I said 7x? What's a like term to 7x?
So you got to think of something that has the same variable that Mr. Roy just said. What variable did he say?
X.
So give us a term that has an x in it.
Any number you want.
8x, perfect.
7x, 8x, like term. Save on. What if I said 15xy? What's a like term of 15xy?
17x1.
There you go.
Perfect. Okay, you guys got it? So here's an example like Mr. Roy just said, 3x, 2x. 5y squared, negative 8y squared. Okay? 2xy, 9xy. Those are like terms. Each term has the same variable, and every variable has the same power. Okay? So all kinds of examples of like terms. How about something that's not a like term? Can somebody name a term, and then give me a term that's not like it? So you just give me one, and then I'll have somebody give me another one. Clayton, give me a term.
2x.
2x. Somebody give me a term that's not a like term with 2x. Marcus.
7y.
Right.
Yep.
He had x, you had y. Those are different variables. Okay? Yeah. 9m. Okay? What's something else that's not a like term with 9m? Yeah, Katie. X. Perfect. Okay? All kinds of examples. So 2x and 4. Those aren't like terms. Okay? 9y, negative 8x. X and y, they're different. Okay? These are close though. How come these aren't like terms? They have the same variables. There's a y and an x, and a y and an x. Same variables. What's the problem? Why aren't they like terms? Savon?
Y squared and x squared.
Right. You're looking at a different variable that's squared. If you're going to have y squared here, you've got to have y squared here, and you don't. Okay? Here you've got x. There's no exponent. What is the exponent on x if we don't see it? 1. We always assume it's a 1. That's just how we do it. So the exponent here is a 1. Here it's a 2. Okay, these aren't like terms. Why are like terms important? Because like terms can be added together. For example, I think somebody gave an example, maybe 2x and 3x. You can add that and get 5x. Okay? But if you said to add 2x and 3y, I can't add that. You can only add and subtract things that are like terms. Okay? That's important. Okay? Another important thing is this number. Okay, Mr. Roy mentioned that a little bit, the number in front of a letter. That's called a coefficient. Okay, that's a coefficient. Okay? What would be the coefficient in that? 8x squared. Yep?
8.
8. Okay? The coefficient is the number in front of the variable. If I ask you what the coefficient here is, that's a little confusing. Well, do you want the coefficient of the first term, or do you want the coefficient of the second term? Okay? Yeah, I could ask for both. What's the coefficient of the first term?
8.
What's the coefficient of the second term?
3.
3. Okay? You guys get the idea of coefficient? Okay. I already said this point to you earlier. Like terms, kind of jumped ahead a little bit, can be added or subtracted. If you don't have like terms, you can't add or subtract them. So we'll finish up with a few examples of combining like terms. Okay, you have 8y, and you're going to take away 3y. A hint, when you're combining like terms, unless you end up with 0, that's kind of a special case, there better be a y in your final answer. If you just write a number here, I'm going to ask you, where'd all the y's go? Where'd they go? They were here on the left, and they're not here on the right. Unless you get 0, that's a special case. Okay, but you have 8 y's, you're taking away 3 y's. Spencer?
5y.
5y. Perfect. Okay, on a test, okay, what I'd like to see is you circle your answer. Sometimes there's a lot of work. I want it circled so I can find it quick. Okay, easier I can read your test, find your answer, the more likely you're going to get a higher grade. Okay? All right, how about, let's try this one. First of all, are they all like terms? 6x, 4x, 5x. What should I be expecting to see in your final answer no matter what here? Because it's all addition.
X.
There better be an x somewhere. Okay? Question is how many?
15.
Okay, let's check it. 6x and 4x is 10x, and 5x is 15x. Okay? Any question on that one? Okay. I'll try one or two more.
Guys, try that one on your own, see if you can do it.
Okay, so try to simplify that. It says 9 plus 3, and then in parentheses 4a plus 2 plus
Guys,
a. Okay, let's take a look at example 9. What's the very first thing you have to do? Distribute the 3. Right now, nothing's going to happen to the 9. Nothing's going to happen to the a. Okay, so we have 9. When you distribute the 3 to the 4a, what do you get? What's 3 times 4a?
12A.
12a. Am I done distributing the 3? No, I'm only half done, okay? I got to do it to both terms.
Guys, I guarantee you, Mr. Hager's really good at math. This won't take him that long. All right? So you'll still have a couple minutes to pack up your stuff. All right, so just give Mr. Hager and I like 1 to 1.5 more minutes of your time.
Okay, we're just about done. Now we're going to distribute the 3 times 2
Plus 6.
plus 6. What do we still have at the end we didn't do anything with yet? Plus a. Now we're going to look in here and find some like terms. Are there any like terms that you see? Let's start with that 9. Is there anything else you can add to 9 somewhere in there? Clayton?
Add 9 plus 6.
Yeah, you can combine the 9 with the 6. How about the 12a? Is there any like term you can combine with 12a? Yeah. A. So what I just did is I underlined your like terms. Now let's combine them. What's 9 and 6? Yeah, go ahead. 15. Now we have 12a, plus we only have an a. We just have one of them. So if you take 12a and you add one more, Isaiah, what do you get?
You get 13A.
13a. Okay? And that's what you get when you simplify that. Okay? So we're going to give you guys some homework to do. We're going to go over that tomorrow first thing. Okay, so for tonight, this is page 38. This is the chapter review.
Guys, write that somewhere. Write it in your notebook. Write it somewhere. On the agenda, yes, you can write it in your agenda.
Okay? On 1 through 11, you guys just are going to do the odds. Don't do them all. Just do the odds on 1 through 11. On 12 to 17, we want you to do all of them. 20 to 28, do all of them.